Today our topic is about today is our lab number 12 and our topic is about DC motor control. DC motor control using fatigue PLC. First point is DC motor is permanent magnet DC motor. This is a permanent magnet DC motor. And second point of this lab is for DC motor, field is supplied by permanent magnet. And point 3 is the flux due to permanent magnet creating two or more poles. Flux is constant in DC motor. Flux is constant due to this reason. Due to this reason, speed torque and current torque is linear. Now stator of a DC motor not required external power, external electricity power from external electricity power. Okay, stator of DC motor not require the external DC or external electric power supply. Due to this reason, it eliminates iron losses. There is no field control, there is no field control in the DC motor. The motion of DC motor either in clockwise or counterclockwise. It depends upon the current through the armature. Speed of DC motor is directly proportional to the applied voltage now this is the properties of DC motor. Now we have to proximity switch. We will define a proximity switch. This is an inductive type switch. Ferrous material is in contact with close proximity of sensor and on upsetting the magnetic field, it trip the contact of relay. then we have to micro switch. Micro switch. The working of micro switch depend on the hitting of moving part of machine, with the lever, and that hitting activate the micro switch. Okay. Now we have the speed of DC motor is 1000 revolution per second, but due to gear mechanism it is reduced up to 1 revolution per second. Now this is the parts which are going to first I want to introduce it with you. These are the located into this module. This one is the this one is the micro switch area. This is a not connected and a normally connected common point and normally open. Okay, and this one is the proximity motor sensor parts. This is the negative motor terminal, this is the positive motor terminal, this is the proximity sensor. Okay, this is the proximity output terminal. Okay, this is the positive terminal for the DC motor, and this is the positive terminal for DC motor, this is the negative terminal for DC motor, and these terminals are used for micro switch, and this one terminal is the output switch for the output terminal for the proximity sensor. Okay, now we have to use the now we have to move toward the another part which is another important part of this lab is function 88. Function 88 is the function for PWM instruction. This is the PWM instruction. The parameter, it depends upon the parameter Parameter on which it depend upon is one is the T on, other one is the time period, TP, and other one is the T on, TP, and other one is output point. Pulse width, T on is for pulse width. When it is enable or enable equal to 1. Pulse period, okay, and this is one is the OT, pulse output point. Now we have to now we have to move toward the WinPro ladder, and we have to start our new project. So we have to start our new project. In our new project we are using x0 as a open contact with a function 8, which is the move function, and we use a source of 45 and a destination of, and R0 used for our destination. And then in rung number 1 we are using x1 is as an open contact and a function 8 data moment function, and we are using source 200 and destination are not. So this one is used for low speed of a DC motor, and this one is used for the high speed of a DC motor. X3 is used for activation or deactivation of DC motor. This is the pulse width modulation instruction. So we have to use a monitoring page because there is no hardware is not available, so we have to just use our practical up to on the basis of software. We are using two inputs x0, three input x1 and x3, and now we have to run the simulation. So we have to run the PLC. Initially x0 is 1. When x1 is 1 and 1, and when x3 is 1. So this one is used for the speed of a DC motor at low speed, and this one is used for the speed of a DC motor for high speed, and this is on the activation and deactivation. There is no any module in this WinPro ladder for DC motor. So so there's one we have, if the T naught is greater than TP, then it will give you an error. Okay, so we have to look into it by if T naught is, so we have to use T naught as a 300. Okay, and now we have to so it is not possible. Okay, now we have to stop and run it again. Okay, it cannot be possible. So it is on. Okay, so it is our 10_1 part. So this X naught is used for to move the DC motor with a low speed, and this is used for to move the DC motor with a high speed, and this is used for activation and deactivation of DC motor. Now we have to move toward the another part of Unit 10. Proximity and microswitch. So proximity and microswitches. Proximity and micro switches. Proximity switch are proximity switch may be inductive, may be capacitive, may be eddy current basis, capacitive, and maybe eddy current basis. So inductive in a sense the ferrous material surround the surround the magnetic field, upset it and hit the lever and activate the switch. It may be capacitive. The ferrous and non-ferrous material used for plate, used for plate, used for plate and with dielectric material and with dielectric material and dielectric material when changes the voltage. These changing voltage rise to activate the contact. That's why this proximity switch is known as a capacitive switch, capacitive proximity switch. It may be eddy current basis proximity switch. EM field generated by sensing coil is absorbed by metal target and which give rise to contact tripping of the relay. So this is working as on the basis of eddy current basis. Okay, now we have to move toward the diagram. WinPro ladder, we have to use new project. So in this project we have to we use X3 to on off the DC motor. To on off the DC motor, and we use X8 for the receiving signal activation signal from micro switch. So we use a function of addition. So SA is used for R0 is used for SA, and it is incremented by using SB, and it is saved in again in R0. So this is used for the receiving of activation signal from micro switch. Now we use X9. and use a second register for SA and increment its value for SB and save in R2. And so this x9 will due to x9 this move function will receive the signal from proximity sensor. So we are receiving a signal from micro switch and another signal from proximity sensor, and now we have to clear these two registers by using x7. So we are using a function of move, which is function number 8, and 0 is used for S, and for destination we are using R0. So we have to clear R0 and R2. So we are using a data movement, so we have to clear now R2. So when we look into this whole diagram, we are using X3 to on off this DC motor, and X8 and X9 is used for getting observed value from micro switch. This is used for absorb value from micro switch, and this one is used for absorb value from proximity sensor, and R0 and R2 is used for clearing of these two registers. Okay, R0 and R2 will be now clear out. So there is no, again we have no hardware, there is no other way to implement it, but we have to try it. So we have input x3, x8, x3, x8, x9, x7, and we have to use R0, R1 and R2. So now we have to run it. Click on simulation. So we have to run it. So the value of R2 is now 0. Okay, we have to put this R1 value 300, and okay, we have to stop it. We have to change the value 300 and we have to use R2 as a 500. First we have to off these switches. Now we have to off this one also. And off this one also. Now we have to run it. And we have to on this X3, so it will on the DC motor. When we have to off it, it will off the DC motor. So in on condition we have to on it, and then we have to get absorb a signal from micro switch by using X8. So we have to on it, so it is receiving a signal from micro switch. Okay, it is continuously increasing, incremented. Now we have to again X9, and we have to increase the we have to increase the so we have to observe one signal from proximity sensor. So after this one will be increment, and its value is equal to 2001, and the value of value which come from micro switch is continuously increasing, which is okay. We have to, it is continuously increasing. The value come from micro switch is continuously increasing, and when we have to again when I have to off this input from proximity sensor, and then I have to on it again, it will increment it. And then it is off. It will no effect on it. Okay, first time it will increment or its value by activation from proximity sensor. Now our NOT value will increase to 1457, and this R2 value increase to 2001, and this X1, when I will on this X1, it will clear these two resistor R0 and R2. Okay, now these two value will clear out. Okay, so this is the lab experiment 10_2. Now we